So this is the first part of interpreting graphs, 1.5, and yeah, what I like most about function notation is we can have two graphs on one. But before we get into the graphs, we can just remind ourselves that this means h of 3 equals 2 means that when x equals 3, h of x is h of 3 is equal to 2. That means your y value is 2. So if this were on a graph, it would be at the order pair right 3 up 2, right there. But we're not talking about that for this graph. So what I like about this problem is we can then put a graph for f. I'm going to do this in green as the dashed line. So f is my green dashed line. Wish I could draw straight. I didn't color code this because I knew I was going to have this as a piece of paper, or in black and white, I guess I should say. And let's do purple for g of x. G of x is the solid line. So this solid line right here. Now there's a reason why we have an open circle and a closed circle, so just remember that as I go from one to the next. At some point I might actually go back and erase some of these lines so it's clear what was intended with each one of these values. So anyway, so when we ask for f, that's telling me to go to the green dashed line if you did color code. And when x is -1, so I go to where x is -1, go up on my graph. And mine is not very clear, so I'm going to count 1, 2, 3, 4, 5, 6. The y value is 6 for that one. So if we look at f of -9, that's when x is -1, 9, 1, 2, 3, 4, 5, 7, 8, 9. Well, this is your open circle, so there's no solution. It is undefined at x is -9. So then looking at f is 5, again green, 1, 2, 3, 4, 5, 1, 2, 3, 4, -5 if I counted correctly for that value. So what I like so much about this notation is now all I have to do is switch over to my purple g function, and when I look at -3.2, I'm just going to approximate, as it doesn't look like it's exactly 1 point something, but it's definitely this value. I'll say about 1.8. Just round it. By the way, if you ever see squiggly bacon symbols, I had a student once call them bacon symbols. That's why I get that name from. That means approximately. So then moving on to g, when x is -11, I believe that's -10, -11. This one is a defined point at -2. The y value is -2. And then g of 7, 1, 2, 3, 4, 5, 6, 7. I can't really tell what that point is. So let me go back and erase. Looks like it's supposed to be exactly -1. So when x is 7, the purple function is g, the y value is -1. So as we move to the next part, I'm going to be done color coding, but if we're adding functions together, it's basically saying take f of 3, whatever that value is, and add to it g of 3. So basically take the green function, or the dashed line, and add to it the purple function. And you need to find both x values. So it looks like this one's supposed to be -6, and this one's supposed to be +6. So if you do -6 plus 6, you get 0. So here's another one that it's basically just say find f of -3, find g of -3, and subtract them. Now the order doesn't matter, so make sure you do the green function before the purple function, or dash before dotted, solid, sorry. So f of -3, again, is my green, is looks like 6, and then my purple is 2. 6 minus 2 would give me 4. And then same thing with the next one. Again, with subtraction, the order matters. So make sure you do g of 9 minus f of 9. Well, Well, if I look at 9, well, they're both the same value, so if you do -3 minus -3, you'll get 0. So if we look at the next problem, it's still 2 times. You have to figure out what f of -4 is, which is the green function. That's 6 minus g of -6. G is purple. 2, 3, 4, 5, 6. That's -2. Don't forget when your order of operations to multiply, then add, because remember subtracting a negative is adding. So 12 plus 2 gives me 14. Yeah, and just continue on. So g of -8, that's that purple function, -2. F of 0, looks like f of 0, the green function. I may have to erase that because I can't really tell now. F of 0 was supposed to be 3, whereas g of 0, it looks like it's supposed to be 4. Make sure that you add in the numerator before dividing. So I would write this answer as 1/4. I like fractions, by the way. So looking at the next one, -2 is still there, times g of 8. Find 8. G is my purple function. I think that's supposed to be -2. Minus 3. Uh-oh. Well, where's g of 17? I don't know if you can tell anymore. But this is supposed to go on forever. So you can see at, I believe this is 11 as -2. At 13 would be -1. At 15 would be 0. So at 17 would be 1, because you can extend that line on. Another way to figure that out is you could actually find the equation of this line. Think about the equation being y equals mx, so the slope is 1/2 x. And then if we extend it backwards, I think the y-intercept would have been -7.5. And then you'd see, when you plug in 17 here, half of 17 minus 7.5, you'd get 1. Excuse me. So 4 minus 3, as you multiply before you subtract, you get 1 as that answer. So the next part of this is where it starts to get a little bit more confusing. But f is still my green line, and because it's written as y equals, just remember, y equals -6, what you want to do is create a horizontal line at y equals -6 and see where that intersects the green function. And it definitely intersects right here at x equals 3. And it looks like that's the only time that they intersect when we scroll down a little bit. So same thing as we look at the next one. Let me change colors again. F of x equals -3. This is the same thing as y equals -3. 1, 2, 3. So that's down here. Looks like now we have 2 different times that the the green, because remember f I drew as green, crosses that function. Looks like x equals 2 and x equals 9. And then you can think of this one in the same way. Y equals 6 is a horizontal line at y equals 6, which is up here. And this time, when they cross each other, the green and the pink actually cross at all of these points. So I'm a big fan of interval notation. I would write that it's crossing at all values between 1, 2, 3, 4, 5, 6, -6 all the way to -1. And I think all of you are familiar with interval notation, that we put brackets when we want to include those endpoints. And so this is saying all values for x that are bigger than -6 but smaller than -1, including those endpoints. But you may not have noticed, there's one more time that f of x, that green function, crosses my pink function. And I don't know if you noticed, but we had this arrowhead on the side that does go infinitely up. And that's actually why I created this equation earlier, is because I can set this equation equal to 6, add 7.5 over, so I'm at 13.5, and multiply 2 to solve for x. And please double check my math. That value would be at x equals 27. All right. Same questions down here. Let me switch back to the other colors where g of x equals -6. So if I go back, this was my -6 line. Did my purple curve, did g ever cross? No, there's no arrowheads on either side. So this is undefined, or there's no solution. I like writing the symbol for no solution. As we look at g of x equals -3, this time the purple function did cross. Now it does go this way as well, but that does not cross at x equals 9. And then also looking at my y equals 6. Oops, it snuck up on me. It says y equals 4 now. So I really should change colors as well. Y equals 4. This time it does look like there's 2 times. At x equals 0 and x equals 1, 2, 3, 4. X equals 0 and 4. Okay, so I'm just going to answer these last 2 and then do the second part of section 5 with a new video. So the key to this problem now is we're introducing a new function, p of x. So I'm replacing p of x with what it's equal to. And I can figure out what g of -3 is equal to by looking at my graph. Again, g is my purple function, 1, 2, 3, it goes up to 2. And now what I can use is, because this is a quadratic, I can set this equal to 0 by subtracting 2 over. And now I can factor this, because there's 4 factors of 15, but the 2 factors of 15 that add to be 2 are 5 and 3. I'm assuming you're good at factoring from Algebra 2. And to make it a positive 2 is if 5 is positive and 3 is negative, because 5 minus 3 is positive 2. And then our zero product property would tell us that x could be -5 or positive 3. And same thing with this one. What I would do is set q of x equal to what they give you. And what is f of 5? Well, if you go to your chart, the green function is f, where x is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. It looks like -5 equals -5. So from this, I can subtract 4 over. Subtracting 4 over gives me -3. Divide by -3. And then don't forget that you get 1 for the absolute value, but what's inside the absolute value could also be a negative value. It could be -1, because the absolute value will make that -1 into a positive 1. So think about that as we progress through this assignment. I'm adding 3 over it, by the way, to get 1. Adding 3 over on this one to get 2. And think about, there might be a situation where the absolute value will have no solution. And think about what that situation might be. Quick mistake here. I'm glad I caught it before publishing this. Is subtracting 4 over was supposed to give me -9. -9 divided by -3 is positive 3. So this should have been -3 as well. And now when you add 3 over, you'd get 6. Adding 3 to this one is 0. So 6 and 0 are your 2 answers. Now I'll move forward.